In the previous video lesson, I talked about these first three properties here. Well, I guess I'll just number them 1, 2, and 3. We used those properties in the worksheet that we did yesterday, and in some of the problems, we needed to use all three of them to simplify one power. Today, we're going to be talking about properties 4 and 5, and we'll be using those in conjunction with the previous three. If you've not already watched that video lesson that covers the first three, you'll need to do that so that you'll be able to use those properties in some of the problems that we'll be looking at. Here we see the division of two powers that have the same base. So a to the fifth is being divided by a cubed. If we expand this, you can see that this has already been done. A is written out 5 times in the numerator and 3 times in the denominator. Notice that any number over itself simplifies to 1. So we have reduced with all of these little red lines, and now I'm marking it with blue, but we've reduced all of the common factors here that will simplify to 1. Those reduce. These reduce. These reduce. And that leaves us with 2 a's being multiplied in the numerator. So that's why it hasn't been written over 1 here. It's because it's just in the numerator. And that simplifies to a squared. This could all be skipped, all of this expansion, and we could go straight from the problem to the answer as long as we understand that the simple way to do that is to subtract numerator exponent minus denominator exponent. Or in other words, the 5 minus the 3, which is what they've done over here. Okay, let's look at some examples. Example 1a here, I've got like bases, 7s, and I've got different exponents, the 13 and the 8. Again, this is going to be the numerator's exponent, so the 13, minus the denominator's exponent, so the 8. And this would just simplify to 7 to the 5th power. I'm not numerically going to figure this out because I'd need a calculator for that. When the bases are smaller numbers, though, we probably will actually evaluate. Example 1b is going to be, well, I've got the base of -1, again, for both numerator and denominator. And to apply this property, I would take the 6 minus 2, which is just going to simplify to -1 to the 4th power. Okay, on problem C. First, I actually need to do the property where the numerator all combines to 1 power. That's going to be 2 to the 3rd power plus the 9th power. Since those are both in the numerator, they're going to combine with addition, which goes back to a previous property. Let's go back to that real quick. Okay, so it looks like for that part we applied property 1, where I'm multiplying powers with like bases. I should add those exponents. And we'll finish that in just a moment, but that's over 2 to the 4th. Okay, so the numerator simplifies to 2 to the 12th. Denominator still 2 to the 4th. And then we apply the quotient of powers property to get 2 to the 12th minus 4th becomes 2 to the 8th. That's as simple as I can make that. Again, unless I pulled my calculator out to evaluate what 2 to the 8th is. Let's take a look at the next one. Let's remember that y to the 18th is really over 1, so the y to the 18th is in the numerator. This is going to make y to the 18th over y to the 7th, because when I multiply the 1 times y to the 18th, that's what I get for the numerator, and when I multiply y to the 7th times 1, that's what I get for the denominator. Now we're going to apply this property and get y to the 18th minus the 7th, and that simplifies to y to the 11th. And that's as far as I can take that. So that's applying that first property. Let me go back to this page of properties here really quick and just explain one quick thing. It says that a is not allowed to equal 0. The reason for that is if you have a 0 right here in the denominator, that means you're dividing by 0. And mathematicians have not defined what that means and have left it as what's called undefined. So, to make sure that we don't run into that issue, we make sure that we set up and say a is not allowed to equal 0. Likewise, for the other property, b is not allowed to equal 0 because b is what appears in the denominator, and we don't want to be dividing by 0. Okay, for the fifth property from the original page there that had the 5 properties, this one is called the power of a quotient property, where we are raising some quotient, the quotient of a and b, for example here, to some power, and so that's going to be raised to the 4th power. If we expand this, that would really be a over b times a over b times a over b times a over b 4 times, which has been expanded here. And that can then be combined using multiplying fractions. So all of the numerators get multiplied together. So we've got a times a times a times a. Denominator is b times b times b times b. And that would all simplify to a to the 4th over b to the 4th. Now again, the property is just trying to help us skip under all of this expansion, which is a ton of writing and unnecessary, and trying to save us time by knowing that we can drop those parentheses from the problem as long as we realize everything in there is going to be raised to the 4th power. And so if this was really, suppose the problem actually said a squared over b cubed to the 4th power, we would then have to apply that other property. Let's go back and look at that really quick. That would be property 2 there. Property 2 is going to say whatever is inside the parentheses then is going to be multiplied by, or its exponent will be multiplied by the exponent that's outside the parentheses. So for my example here, this would become a to the 8th power over b to the 12th power. And so this 4 actually got applied to both of the exponents and got multiplied to those. And that's a combination of this power that this property that we're looking at, the power of a quotient, and the property number 2 that we were looking at earlier. Here are some examples. Let's apply this property. So a is simply going to become m to the 5th over n to the 5th. And problem b here is simply going to become 3 cubed over p cubed. And since 3 is such a small base and cubed is such a small exponent, I think we can simplify or actually evaluate that one to 27 over p to the 3rd. Okay, here are a couple of problems that are actually going to make me apply any and all 5 of the properties that were on the initial screen. If you haven't gotten those in your notes, you probably should. It's not on the paper that I made of notes. Those 5 properties altogether are only found in this video lesson. I probably will write them on the board at some point, but you should certainly know how to use them and have them in your notes. So example 3a here. I'm going to use that property that applies what's outside the parentheses to all of the bases inside the parentheses. That's going to give me 2 squared x to the 6th, because that gets multiplied to the 3, the 2 times the 3. And in the denominator, I've got 5 squared and y to the 4th. Really all I can do at this point is to simplify the numerical powers. It's going to be 4x to the 6th over 25 y to the 4th. Now if my variable powers had like bases, so the x and the y, if those were like bases, then I could do the 6 minus 4 and move on from there. Or if 4 and 25 were had common factors, I could simplify my fraction. But since none of that is true, this is as far as I can go. Okay, last problem. Example B here is going to become 3 squared, k to the 6th, over 4 squared, l to the 10th, times, I haven't done anything with this one yet, so I've got l squared over 6k squared. Since these fractions are being multiplied together, I'm just going to extend the fraction bar like that, because that really implies that there's multiplication going on there and there. Let's take a look at this now. I can simplify 3 squared to 9, k to the 6th, and l squared are going to be that. Then in the denominator, this is 16, and 16 times 6 is 96. And that won't reduce with the 9, so I'm good there. And I've got k squared over l to the 10th. Actually, they do reduce to 3 over 32 here. The explanation required to finish this problem is going to take too long, and I've already gone over 10 minutes, because there are more L's in the denominator than there are in the numerator. And that's something that I don't want to address until we get into the negative exponents video lesson. So I'm just going to leave this problem at this for now. In the two problems that I would like for you to do, you will not run into that issue. So please do these problems and have them prepared for putting your answers down on warm-ups soon. Thanks. Good luck.